Space, the final frontier. But it's not as empty as we once thought. Every day, millions of asteroids zip through our solar system. Some are tiny pebbles, harmlessly burning up in our atmosphere, but others, they could spell the end of life as we know it. Asteroids are rocky remnants from the dawn of our solar system, leftovers from the formation of planets over 4.5 billion years ago. These celestial bodies vary greatly in size and composition. Most of them reside in the asteroid belt between Mars and Jupiter, but not all of them stay put. Some are knocked out of their orbits and stray much closer to Earth, and when they do, they can be incredibly dangerous. There are three main types of asteroids: C-type, S-type, and M-type. C-type, or carbonaceous asteroids, are the most common and contain clay and silicate rocks. S-types are siliceous and made up of nickel iron mixed with iron and magnesium silicates. M-type asteroids are metallic, primarily composed of nickel and iron. The type of asteroid determines how dangerous it could be if it were on a collision course with Earth.
Asteroids vary in size, from as small as a grain of sand to as large as cities. While most small asteroids disintegrate upon entering our atmosphere, larger ones, those over 140 meters, could cause regional or even global devastation. And these are the ones we are most concerned about.
To understand the potential danger of asteroids, we must look back in time. Imagine an asteroid the size of a football field hurtling toward Earth at over 20 kilometers per second. Upon impact, it would release more energy than the most powerful nuclear bomb ever detonated. Such events are not merely hypothetical. They have happened before. In 1908, a small asteroid or comet exploded over Tunguska, Siberia, flattening 2,000 square kilometers of forest. The explosion was so powerful that it could have destroyed a large metropolitan area if it had hit in a more populated region. And 66 million years ago, a massive asteroid around 10 kilometers in diameter struck what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. This impact unleashed a chain of events that led to the extinction of about 75% of all species on Earth, including the dinosaurs. These events are not just stories, they are powerful reminders of the cosmic dangers we face. Today, we are better prepared than ever to detect these celestial threats. Scientists around the world are on a constant lookout, tracking thousands of near-Earth objects, or NEOs, that could pose a threat. These include asteroids and comets whose orbits bring them into close proximity with Earth. NASA, along with other space agencies, has developed advanced early warning systems and is even testing ways to deflect asteroids. Recently, NASA's DART mission successfully altered the orbit of an asteroid for the first time in human history. The mission aimed to test our ability to change an asteroid's path, a critical technique for planetary defense. This mission demonstrated that with enough warning, we might be able to prevent a catastrophic impact. But the reality is, not every asteroid is detectable and not every asteroid can be deflected. Smaller asteroids, the size of a bus or smaller, are harder to detect until they're dangerously close to Earth. These smaller bodies, though less devastating than their larger counterparts, can still cause significant damage, especially if they explode over a populated area, as happened in Chelyabinsk, Russia, in 2013. The Chelyabinsk event was a wake-up call for the world. The asteroid, only about 20 meters in diameter, exploded with a force of about 500 kilotons, injuring over 1,500 people and causing extensive damage. This incident reminded us that even smaller asteroids could pose a serious risk.
We are in a cosmic shooting gallery. It's not a question of if another asteroid will hit Earth, but when. Our efforts now are focused on developing and refining technologies that can protect us from these inevitable impacts.
One of the biggest challenges we face is ensuring global cooperation. An asteroid impact is not just a local or national problem, it's a global one. All countries must work together, sharing data, resources, and strategies to safeguard our planet.
The potential scenarios of an asteroid impact vary, depending on the size, speed, and composition of the asteroid, as well as where it strikes. An impact in the ocean could trigger tsunamis, while a land impact could cause wildfires, earthquakes, and widespread destruction. What would happen if we found out an asteroid was heading toward Earth right now? Would we have enough time to prepare? Would we know where to go or what to do? Emergency plans are being developed by governments and agencies worldwide, but they all hinge on one crucial element: time. The earlier we detect an incoming asteroid, the better our chances of survival. But if we don't spot it soon enough, the consequences could be dire. Preparedness is key, not just for governments and scientists, but for all of us.
It's essential that people understand the risks and have a basic plan in place, just as they would for any other natural disaster like a hurricane or earthquake. Knowing where to go, what supplies to have, and how to communicate with loved ones could make all the difference.
From up here, you realize just how fragile our planet is. It's our only home, and we must do everything we can to protect it from cosmic threats. We have the knowledge, we have the technology, and now we need the will to act.
Asteroids may be silent and hidden, but they are not forgotten. As we look to the stars, let us also remember to keep one eye on the space rocks that roam our cosmic neighborhood. Our future may depend on it. The dangers are real, but so too is our capacity to respond. Together we can protect our planet and ensure a safe future for generations to come. If you enjoyed this video and want to learn more about the dangers lurking in space, don't forget to like, subscribe, and hit the notification bell. Stay curious, stay vigilant, and keep looking up.